I will be presenting assignment 2 on Bernoulli's principle and fluid flow analysis. This assignment applied to the continuity equation and Bernoulli's equation to determine the velocity and pressure at different points in the pipe system. In addition, Power BI is used to visualize the relationship between velocity and area as well as pressure and velocity. For the first step, I'm breaking down this fluid dynamics problem based on my metric number 3741. Let's define our variable for point 1. We're working with an area of 3.0 square meters, a velocity of 7 meters per second, and a pressure of 41 kilopascals. Since my metric number ends in an odd number, the rule states I need to subtract 2 square meters from the area. That leaves us with an area of 1 square meter for point 2. To find the velocity at point 2, we use the continuity equation. A1 V1 equals to A2 V2. Plugging those numbers in, 3 times 7 equals to 1 times V2. We get the velocity of exactly 21 meters per second at the second point. Now for the pressure at point 2, we're applying the Bernoulli equation for a horizontal pipe. So for this formula, we get to rearrange this to solve for P2. By substituting our density of 920 kilograms per cube meter, which is the standard density for olive oil, along with our calculated velocities, the math leads us to a pressure of negative 139.32 kilopascals at the second point. Next, I sum it all in the table to put all the calculation in Power BI. Next, in this tutorial, I'm demonstrating how to visualize fluid dynamic data in Power BI. By organizing this data this way, we can clearly observe how these physical properties interact. So before we moving on with the result, let me explain a bit about Bernoulli principle. So it states that for an incompressible and frictionless fluid flowing steadily, an increase in fluid velocity causes a decrease in fluid pressure. So next, this is the result that we extract from Power BI. We have two graphs. For the conclusion for graph 1, the velocity versus area graph shows an inverse relationship between velocity and cross-sectional area. As the pipe area decreases from 3 to 1, the velocity increases from 7 to 21. This occurs because the same volume of olive oil must pass through a smaller area, causing the fluid to move faster. The graph verifies the continuity equation, which states the velocity increases when the flow area decreases. For the conclusion of graph 2, the pressure versus velocity graph shows that pressure decreases as velocity increases. When the velocity increases from 7 to 21, the pressure drops from 41 kPa to negative 139.32 kPa. This trend is consistent with Bernoulli principle, which states that an increases in fluid velocity result in a decrease in fluid pressure. The graph demonstrates the conversion of pressure energy into kinetic energy as the olive oil flows through a smaller pipe area. And for the last question, which include real-life application, the Bernoulli principle is used in aircraft wings, which air moves faster over the curved upper surface of the wings and slower below the wing. The faster airflow creates lower pressure above the wing and higher pressure below it. This pressure difference generates lift, allowing the aircraft to fly. And by that, that's the end of my explanation throughout this assignment. Thank you.